Now that you've checked your Douglas bag system, performed a volume calibration and calibrated your gas analyzers, you're ready to collect a sample of expired air. For this you'll require your loose piece of connective plastic tubing, which will be attached at one end to the Douglas bag system. You'll also require a two-way valve, a stopwatch and a nose clip. The two-way valve contains a solid end and a clear end. The solid end allows air to enter when you breathe in, and the clear end allows air to exit as you breathe out. Both prevent backwards flow of air. Therefore, if you attach the clear end to the other end of this piece of plastic tubing, as your participant breathes out, all the air will enter into this tube and pass into the Douglas bag system. It's really important that you don't put this on the wrong end, because if you do, your participant won't be able to breathe in. In addition, if the seal on either the solid or clear end are loose at all, then air is likely to be lost. Therefore, it's important that you check this before you start testing. If you notice that the seal is loose, you can unscrew the end, replace the seal and screw it back in firmly. Place the nose clip firmly on your participant's nose and place the seal of the mouthpiece inside your participant's lips to prevent any loss of air. It is important that you start the stopwatch at exactly the same time as you open the Douglas bag. Here we take a 30-second sample, so it's also important that I close the Douglas bag on exactly 30 seconds. Remember that unless the Douglas bag is open, air cannot enter or leave. Now that I have a sample of air in my red Douglas bag, I can calculate my oxygen uptake, carbon dioxide production, respiratory exchange ratio and my minute ventilation. The first thing I need to do is calculate the fractions of expired oxygen and carbon dioxide in this sample of air. To do this, attach the small red taps at the top to the desiccant cartridge which is on top of the Powerlab. Remove the protective cap from the desiccant cartridge and place it safely on the side, and then attach the tubing in its place. Open the small red tap and open the small white tap nearest to the end at which the tube comes out. At the far end, ensure that the white cap remains closed. Now start the Powerlab, and then we're ready to switch the pump on. When we switch the pump on, make sure that we click start on the stopwatch at the same time. I'm taking a 30-second sample. The reason for this is that the gas analyzer samples at 200 millilitres per minute. So I know that in 30 seconds I'm losing 100 millilitres from my data, which I can add when I calculate the total volume of air at the end. On 30 seconds, switch the pump off and stop the Powerlab. Eyeballing the data, I can see that I have 2.26% carbon dioxide and 17.37% oxygen. Now shut the red tap and shut the white tap, undo the desiccant cartridge and replace the protective cap. I'm now ready to calculate the total volume of air in the Douglas bag. So take the plastic tubing and attach it to the dry gas meter. Make sure that you press reset, open the Douglas bag and turn on the vacuum pump. When the Douglas bag is empty, switch off the vacuum pump, make a note of the volume of air stored in there. And then you need to import this data into your Excel spreadsheet. Your participant's name, stature and mass should already be on the Douglas bag data collection form, as should the barometric pressure, temperature and humidity. Enter the collection time, which in this case was 30 seconds. Enter the Douglas bag volume, the fraction of expired oxygen, and the fraction of expired carbon dioxide. Then use the calculations in your workbook to calculate minute ventilation, oxygen uptake in litres per minute, oxygen uptake in millilitres per kilogram per minute, carbon dioxide production and respiratory exchange ratio.